Now we're going to look at some functions that are a little bit more complicated than the first several examples we did. So we have here this function g of x equals x squared times e to the 1 over x squared. I just want to remind you I gave you this code, but if you were going to get e for yourself, remember that this is not just e on the keyboard. Right, you can find it, there are keystrokes for it, or you can find it in the cap, but if you just type E on the keyboard, it's not going to be the correct E, so just a reminder in case you're having to type E in one of these days coming up. So we start with a graph of G. I just picked the typical negative 10 to 10 on X standard, and it's a very interesting looking function. It looks like it has a vertical asymptote at x equals 0. We see the function, in fact, is not defined at x equals 0 because that gives a 0 denominator of the power on e. So again, our goal is to find max-min's inflection points. It appears that there might be a couple of minimum values based on the picture. I'm not sure exactly where they are, but maybe somewhere around in here. So again, I'm going to take the first derivative. I ask Mathematica to find that for me. And then I use the simplify command to try to just get it in a little bit easier to read format. And actually that does help a lot when I see the simplified version of G prime. I can see in the numerator here something that I could easily set equal to 0 myself. So when I use the solve command to find where g prime equals 0, I'm not surprised at all to see x equal plus and minus 1. That makes sense with the piece that I circled up above. I also can see just by looking that g prime is undefined where the denominator is 0, and I see that that's where x equals 0, but I notice that the solve command, right, again, doesn't really do the right thing. If I'm setting the denominator of g equal to 0, I should get x equals 0, and I don't. Now again, this one I can tell just by looking, but I did the second solve command just to demonstrate. I could type in or copy and paste that denominator expression. In this case, it just happens to be as simple as x. But for future reference, you could, if you don't think that denominator command is working properly inside solve, you can copy and paste the actual denominator expression yourself and set that equal to 0. Now note to self, x equal plus and minus 1 are critical values, critical points, critical numbers. That's where the derivative equals 0 and those values are in the domain of g of x, whereas x equals 0 is not a critical number. I'll say CP for critical point, not in the domain of g. So they cannot be considered critical points or critical numbers. You could potentially call them key points. And so I have critical numbers at x equal plus and minus 1, which again, just looking at the graph of g, looks like that might be where the two minimum values are. At x equals 0, this is a critical point, is not considered a critical point, but maybe we can call it a key point. And actually, I shouldn't say these. I should say this. There's only one. And remember, the function can change either behavior, increasing, decreasing, or concavity on either side of a place where the first derivative is not defined, so we still have to sort of check it out, even though it's technically not a critical point. So now the next thing I did was evaluate g prime at these various and sundry places So again, if I were to set up a number line, I would put the critical number values, x equal -1 and x equal 1 on that number line, and I would also put my key point, x equals 0, where the first derivative is not defined, but again, that's not in the domain of G, but I still want to look into it. And so I plug in x values into G prime that are on either side of these places, and I see that my G prime goes from negative to positive to negative to positive on either side of these spots. And so that tells me that G goes from decreasing to increasing to decreasing to increasing. So I have a relative or local min at x equal -1, and I have a relative or local min at x equal +1, and I can't say anything at x equals 0 because it's not in the domain of G, but I can say the behavior of G changes on either side of the y-axis. So I can tell that, and I should test those points as I did at G prime of -1/2 and G prime of +1/2 to see if anything happens differently, and in fact the behavior of G does change from increasing to decreasing, so it was important that I looked into that, but also important that I don't get hoodwinked into thinking, oh, so I've got a relative max at x equals 0. I don't. The function does not have a relative max at x equals 0. Okay, next I want to look for possible points of inflection, so I find my second derivative. Again, I just ask Mathematica to find that derivative for me. And notice this time, instead of using simplify, I'm using this together command, which usually together and simplify can have similar effects. And so that creates a single fraction of G double prime, so I can see more easily what's going on. Now I try looking for where the second derivative is 0 or undefined as possible places where I might have an inflection point. The second derivative, I set it equal to 0 by setting the numerator equal to 0, and I get no result. So here's again a case where I actually then copy and paste the numerator of G double prime and set that equal to 0 in the solve command. Notice in the original solve command here I had asked for solutions in the reals. Here I just said give me my answers in decimal form. And I notice that my solutions all have the imaginary number in them. So in fact, my original solve command on the numerator of G double prime apparently did work. There were no real solutions. But just to be sure, I pasted that numerator into the solve command and asked it to find me decimal solutions, and I see that they all are imaginary. Now again, I can just see with my own eyes that G double prime is undefined when x is 0 because I see the denominator is x to the 4th. So rather than use the solve command, this time I just used my own brain. And so I do now create a number line, and I put 0 on it, and I check the sign of G double prime on either side of 0, and I see positive 4e, positive 4e, so G is concave up and then still concave up. So the concavity of G did not change on either side of 0. So let's go back and look at the function G again. What happened is it changed from decreasing to increasing at x equal -1, and then it did change from increasing to decreasing over the vertical axis, and then it changed from decreasing to increasing at x equal +1, and at both of those places I do have horizontal tangent lines where the derivative is 0, so the slope of the tangent line is 0, and I have relative minimum values. The concavity of G never actually changes. It's concave up to the left of the vertical axis, and it's concave up again to the right of the vertical axis. And so there weren't any inflection points of G. I tried looking at where the derivative is 0, and it never equaled 0. I looked at where it was undefined and checked the concavity on either side of that, and it was concave up on both sides of x equals 0, so there was no place where G changed its concavity, so G does not have any inflection points.